So it was great to hear from Elizabeth Stark about the Lightning Network. I'm really excited that we're at a point today, the network's seen explosive growth, where we can come up here and talk about it for 2 hours. Today, I'm going to be covering more of kind of a less technical, more user experience side of Lightning, actually using Lightning on the web for payments and a few other things. So I'm going to talk a little bit about where we came from with Bitcoin payments and where we're going next. So a little context about me before I get started. I work on a browser extension called Joule. It plugs your Lightning node into your browser to make this whole payment experience on the web a lot better. But before we can talk about Lightning, we got to look back at Bitcoin. So Bitcoin payments on the web were kind of a tricky thing. We envisioned it as this peer-to-peer digital cash system, but it came with a lot of problems. One is that you need to send an address and an amount to somebody, right? But mistakes can happen along the way. You could potentially send to the wrong address. You could send the wrong amount. You could actually accidentally send twice. A lot of things could go awry in there. And unfortunately, sometimes depending on who you were sending it to, they might not want to fix your problem. You had to deal with long confirmation times and implicit expirations on those payments. So if you set a low fee or the mempool was really full, your transaction might take too long, and they may decide that they don't like the price of Bitcoin anymore for your transaction. So you kind of had to deal with this slow, asynchronous process. Maybe you get emailed later at the end. High fees made mid and small-sized purchases infeasible. So if you want to pay for a cup of coffee or you want to buy a sticker pack online, wasn't really a great use case for on-chain payments. And as you're making multiple payments around the web, you were faced with this problem where you either had to give up privacy or convenience. You had to either have a new change address for every transaction you make, causing this UTXO buildup, or you had to set the same change address, which anyone could publicly see all the purchases that you made and tie it back to a single address. So there are a lot of things that made Bitcoin payments on the web a not great user experience. So fortunately, Lightning comes around, and we see a lot of improvements on that front. So let's talk a little bit about what Lightning payments on the web look like today. So payments are done through invoices. The server usually provides the user an invoice, and the user pays to that specific invoice. Invoices are these encoded strings that contain like a set amount, an expiration date for that payment, where it's going, and they only work once. So you're always going to send it to the right person, the right amount, within the right time limit, and you won't send twice. So that's a really cool feature. And once those payments go through, they settle nearly instantly. So you don't have to wait for an email, block confirmations, all that. It happens right away. Unfortunately, though, Lightning payments do come with problems that we touched on a little bit before. Sometimes you can have routing issues with your payments where you can't find a route to the server that you're paying to. And even worse on this front is the server doesn't know you're experiencing that problem, so they can't help you out. They don't have a way of offering advice to you. They have no idea what's going on. It's totally opaque. And to actually make this payment, you have to switch to like another application or pull out your mobile app, scan a QR code. So it's still a pretty high friction situation. And high friction payments are really bad because they lead to very anti-user practices. So when you frequently have to stop a user to ask them to pay for things, it's bad for the user experience, and it's probably bad for your site metrics. So your boss is going to say, forget this Lightning micropayment thing, because users are bouncing every time we ask them to pay. So it kind of leads to these things like bulk purchases of like tokens that you get to use. Here we have Fortnite V-Bucks, and you do not want to be Fortnite V-Bucks, right? And you don't want to have long-term subscriptions. You want people to pay for only the content they use. That's like a very good user practice. And sometimes if you don't use these tokens or your subscription, you don't end up using it, you're not going to get your money back, right? So it leads to these kind of predatory practices amongst businesses to get you to pay a lot of money up front. Another trend that we're seeing today with Lightning apps is you have these custodial nodes. So here we have Koala Studio on the right. The idea here is because this payment process is kind of annoying, they have you deposit a lot of money up front, and a lot of sites are doing this. So you make one payment up front, and then that payment is tracked in a database that they control. And when you want to withdraw your money, you give it an invoice, and they pay out to that. So none of this is happening on network, which is fine. But you're locking your liquidity up on these sites. So if every website you have a deposit with, well, you're moving liquidity from your node into their node, and you can't spend it elsewhere. So the more sites you use like this, the more problematic it is. It also doesn't take advantage of the network effects of the Lightning Network. We can route to each other, we can pay to each other, but we're still in this hub and spoke model of paying into these central services. Another kind of interesting thing that has come out of using Lightning on the web is this variable purchase permanence. So if you want to buy something and have it saved, you have to have a traditional login. That's pretty normal, like a username and password or logging in with some service. But a lot of purchases are so small that they just tie it to the device, and there is no way to get it back. So here you can see yells.org. I bought an article on my desktop, and when I went to open it on my mobile app, I got hit with the paywall again. And the payments are really small, so it's not that frustrating, but it can be very confusing to users that things that they pay for they can't get again. So we're seeing this a lot. Sometimes these purchases are totally ephemeral. They're so small and so meaningless that like once you navigate away from the context or reload the page, you don't have the payment anymore. So in summary, like we've improved a lot over Bitcoin payments for sure, but when it comes to using something like PayPal or whatever, a lot is still the same. Making payments is still this high friction experience, more so in the case of routing issues. Payments between users is still generally managed centrally in some kind of custodial node in the middle. Micropayments are still just not a viable user experience. You can't put paywalls up in front of users every step of the way. And if you want to save user purchases and ask them to buy more meaningful things, you're still going to need them to like log in, give you personal information so that they can recover those purchases later. So we've kind of ended up with like a pretty, it's better than Bitcoin, but it's hard to reason why you would use it over, traditional payment methods. So I'm working on making Lightning apps better with a little spec I'm calling WebLN. WebLN is a standard for providing permission access between a web application and your Lightning node so that you can kind of facilitate that communication more directly. The idea is that the user's client injects a little API into JavaScript that the website can then ask for user permission to be able to do more direct payments. So we're improving the user experience and getting rid of all that friction that we talked about with payments, but we're still preserving the user's security and privacy because it's a permission system. You need to ask for permission to make payments. You can't just, do it right away. And it's not a direct connection to the node. It runs through your browser, which keeps some privacy intact. So what we get out of this, well, for starters, in-app interactions. So the idea here is that you can see a payment being made. And this is happening entirely in the app through an API interface rather than like kicking around URLs or QR codes. And it's a much more instantaneous experience. You don't need to alt-tab to another app. You don't need to pull out your phone. You don't need to copy and paste these long URLs. If something goes wrong during the payment, the API interface can inform the application that something went wrong. Maybe there's a routing failure. Maybe they don't have enough balance. Maybe there's some issue connecting to either of the nodes. Now the application can actually assist the user in fixing what's going on. And in general, we've just lowered the friction of these payments. So now it's not so bad to present a user with a paywall. We're also enabling this peer-to-peer use case. So by automating invoice generation, it's a lot easier to facilitate these peer-to-peer payments. So the typical model you'll see here is that there's some central Lightning node in the middle, and one user pays to it, and then when another user wants to take money out, they have to manually generate this invoice. By automating invoice generation, we can just pass invoices to the server. It doesn't even need to run a Lightning node and just facilitate these payments between users directly. So the money's like never sitting up there. It's always either in your channel or it's in your node or in the node of the person that you're paying. And this is much more of like a decentralized attitude. It's leveraging the network that we're building. Another interesting thing that we can get by directly talking to the node is using your node identity or providing proofs for various things to like establish who you are in the network. So the user can opt in to provide and prove their node identity and then prove that identity with signatures if they want to. And you can potentially have your node provide old payment proofs, these pre-images that you get from transactions. So you could give that back to a website and recover your purchase, and they still don't even need to know who you are. They just recognize that you have paid for something and you have access to it. If you want to have like a free and Sybil-resistant auth option to your website, you could have users authenticate with a node instead of either having to pay to auth with a site or to provide some kind of like pseudo-unique identity like an email and password. You just check that they're a reasonably good actor on the network with channels, and that's it. You can let them in, and they have a unique identity. And you can even encourage and reward users who help you out on the network. So if somebody has a channel open to your service, you could like throw them a discount. That would make sense because they're helping you out by providing routing and liquidity. So some stuff that's still in the works, but I'm really looking forward to, is a confirm-free experience for payments. So before we saw that it kind of popped up this window, but we could have clients configure an allowance per web app to say, hey, you know what? If it's a payment that's below a certain amount within a certain allowance, just do the payment. And that's enabled by having an API interface. You don't have to bug the user. So the app could request an allowance potentially before a high usage activity, like maybe you want to stream a video and charge them for every 10 seconds. Or you want them to browse articles, and you pay for every article they read. So the app can set up the allowance beforehand. So this really gives us like this true micropayment experience that previously hasn't been possible because the user experience has just been so bad. We can also leverage the power of the programmability of our nodes by actually programming them directly. So nodes are just API web services that are, if you're running a node at home, it's on 24/7. So we can actually like use that power to have the node talk directly to services and never have the user involved. So on the right here, this service that I just launched yesterday called TipHub, you upload some authorization to your node, and whenever someone wants to make a tip, it happens directly to your node. The server doesn't hold on to it for you. So this is done because LND uses these things called macaroons for authorization. If you're familiar with cookies on the web, just think of macaroons as like a very fancy cookie. They provide permission access. So I can give them some authorization to my node that says you can only generate invoices. You can't make payments. You can't even like try to identify who I am. All you can do is generate invoices. So with a macaroon and IP, the possibilities are endless of what you can do on the web. And so all these features combined are totally client and node agnostic. So before where you would have to create the interface for all this stuff, now the user's client comes with it. So it's more tailored to their device experience. So here, you've got my extension Joule, but you've also got the Blue Wallet mobile application that provides a much simpler interface, whereas Joule has a lot of like power user features. This spec could be used with any LN node. I'm currently working only with LND, but any node could implement the WebLN spec. It's not tied to anything in particular. And so we've already got some extension uses and mobile apps, and more people are building on top of this today. So by the end of this, hopefully, we end up with very happy users who are having good experiences on the web, and very happy users are hopefully going to make very many payments using Lightning. Thanks, everybody.